Good afternoon, everyone, and welcome to Workshop 1, Getting Started with Cardano Development Basics, a key session in the Cardano Hackathon Asia IBW Edition 2025 with Hack to Skill as an innovation partner. I am Nidhi, and I will be your host for today's workshop. Let me give you a quick overview of what today's hands-on workshop covers. Before we start, kickstart your Cardano development journey by learning the fundamentals, including Cardano eUTXO model, proof of stake, and how wallets and staking operates on the network. Let me quickly give you a quick brief as well of the total prize money for this hackathon. Is the total price of $65,000 dollars stable coin. We have some bonus pools for these for the tracks that we have problem statements that you can win. This is the timeline. Currently, we are in the registration and idea submission phase. Register and form your team of 2 to 5 members if you haven't already, and submit your ideas by November 16th. Shortlisted team will proceed to mentoring and compete in the grand finale happening in the Bangalore live on November 29th and 30th. It's my pleasure to introduce our expert speakers for today's session, Bharat Malapur, Program Director and CTO at Academy Anesthesia Labs, and accompanying him, Arya Putra, Smart Contract Developer. They will guide us step by step through the development basics and answers to your questions as we go. Um, as they begin their session, the Q&A will be happening by the end of the session. Please feel free to leave your comments regarding anything and we'll make sure to address it. Thank you. Please welcome Bharat.
All right. Thank you so much, Nidhi. It's a pleasure to be here. It's been, I think I'm really happy that finally, I mean, there have been some minor hackathons, but this is a good hackathon on Cardano, which has been sort of organized in India and specifically Bangalore. So I am really happy about that. So let's get to the main stuff. How do I present? 1 second. Yes. Share screen. I can just share. I hope everyone can see my screen. Okay, awesome. So welcome everyone. In this session, basically, this is sort of like an easy introduction to Cardano and programming on Cardano. So along with me, I have Aryadi. He's a colleague of mine, ex-colleague of mine, and thankfully he's sort of volunteered to come and explain about the Aiken smart contracts in this component. So what we'll be looking at today. I hope my presentation is still visible. Yeah, okay, perfect. So today what we'll be doing is first, before we start off with the programming concepts and take a look at how do you sort of build a smart contract on Cardano, we'll quickly understand some Cardano fundamentals. These are like the Cliff Notes version of things. There's a lot of stuff which goes into the technology behind Cardano. It's a really amazing blockchain protocol. You can see it has been running continuously and successfully since 2017 without a single down event and not a single hack till today, right? So amazing engineering, amazing technology built. We'll just look at very, very basic stuff, just enough to sort of get you started with the blockchain development aspect of things, right? So we'll understand some Cardano fundamentals, then we'll set up a testnet wallet. We'll set up a wallet, Cardano wallet on the testnet so that you can understand how to get test ADA, which is not real ADA, but you can use it for development purposes, right? So we'll set up that wallet, and then we'll fund it with test ADA. And then after that, I'll hand it over to Ariadi, and Ariadi will take it up for how do you set up your development environment for Aiken, and then how do you sort of take a very simple smart contract and then build it, deploy it, and then interact with it. Right. So going forward, so if you look at Cardano, Cardano is a proof of stake blockchain, right? And it's one of the first blockchains that came up with a very, very workable, very efficient proof of stake algorithm. Today, Ethereum is also, a proof of stake blockchain, but Cardano, from the word go, it has been a proof of stake blockchain. Now, how does it work? Proof of stake? Well, you can delegate. There are some pool operators, stake pool operators, and as a whole, the cryptocurrency holders can sort of say, okay, I want to earn staking rewards on my ADA which I hold, and they can sort of decide, okay, which stake pool is giving the best returns for me, right? And then based upon that, they can delegate. There are some critical factors like saturation, right? If a pool is full of people, then the rewards will be less. So the idea is you have to choose your stake pool in such a way that it gives you the best returns, right? So, but anybody can delegate to a pool. There's no minimum amount or something like that. I mean, beyond a point. And whatever are the rewards, staking rewards. So why do you get these rewards? Because by sort of staking your ADA to the stake pools, you are sort of participating in the security model of Cardano, right? So it means that if majority of the people in the Cardano community, in the Cardano investor community, if they delegate to the Cardano blockchain via staking, basically they are participating in the blockchain security process, right? For that, in return for staking and contributing to the security, you get rewards, right? Now, how does this happen? Basically, there's something called a K factor. It's a technical parameter which is decided in the blockchain, which is used to set the number of active productive pools, right? So I think K500 is the default right now. So basically, all the whatever is the amount of ADA that is in existence, divide that by 500, and you get some sort of figure as to how much one stake pool can control. So this means that no stake pool can control more than that number of ADA, right? So this definitely introduces decentralization. For example, if you see here, over 3,000 plus pools operate worldwide, and well, most of them are operated. I think at least 2,500 to 3,000, 2,800 are quite profitable. I mean, they are able to maintain themselves, right? At the very least, and many of them are making very, very good returns by operating these stake pools. So 3,000 pools is a lot, right? And these 3,000 might seem like, oh, there's only 3,000, but under each pool, there will be like hundreds or thousands of people who will be participating. So the amount of staking that is actually happening is very, very high. Around, I think, 85% of active ADA in the blockchain is actually being staked. So that's a very, very good metric, very healthy metric, right? And the pool operators, basically, it's not that, once you become a pool operator, you just sit and earn money. You have to do a lot of work. You have to compete on uptime, performance, fees, how you contribute back to the community, etc. Right? So you have to build your reputation and build that. So that's where stake pool operating is a full-time job. It's not something which you do on the side if you want to be profitable and very profitable. So this ensures that you have a very dynamic and active stake pool community, right? So now we'll come to a little bit about what is the proof of stake algorithm. So Cardano uses something called Ouroboros, right? Ouroboros is the first peer-reviewed proof of stake protocol. What does this mean? So if you see, there have been other proof of stake protocols earlier, right? Not Ethereum. Ethereum joined the proof of stake queue much later. But proof of stake typically is something that was implemented, but most of the protocols out there, they don't have a mathematically validated peer-reviewed, that is like a educational academia who are experts in distributed systems, networking, etc. That kind of review has not happened for their protocol. Whereas for Cardano, it is mathematically validatable and it is peer-reviewed. Right? So and it has been built in many layers over quite a few years. Right? So it is incredibly secure. Till today, as I said, there has not been a single hack. Now, when you're in a proof of stake protocol, basically you want to build blocks, and these blocks have to be built sequentially over time, right? So first thing you will understand is time on the Cardano blockchain is divided into two major things, right? One is called epoch. So an epoch is basically a time interval of 5 days. And why is it 5 days? Because there's a lot of setup process that happens at the beginning of every epoch, right? So because Cardano does not use locking of stake, which means if you have put your if you put your ADA for staking, you're not locked in. You can withdraw them, you can transfer them to anybody else at any given time, right? So to make sure that your rewards calculation is accurate, at the beginning of every 5 days interval, a snapshot is taken of all, the exact ADA that is held by all the investors, or by all the staking by all the stakers, right? Based upon that, this snapshot, then over the next 5 days, you will not have any more snapshots being taken. At the end of 5 days, you'll get paid, right, for whatever blocks have been created based upon your activity. Now 5 days is like, it's only for staking rewards calculation, right, and distribution. So how do the blocks actually get created and positioned in the blockchain? We use some concept called slot, and there is one slot per second. Historically, it used to be one slot every 20 seconds. Now it has been made one slot per second, right? So what is a slot? A slot is a potential placeholder where a block could be added. So that means if you have in 1 second you have one slot, potentially you could have one block per second, right? But as of today, there is a limitation because the scaling is not really that required. The amount of traffic, etc., you don't really need to have that kind of thing. And also there's propagation delays, etc., which still have to be, the network has to become much faster. So you can say that blocks as of today can be produced only once per every 20 slots. So it is one block is every 20 seconds on average. It does not mean that it's exactly at 20-second intervals, but if you look at the entire blockchain produced till now, on an average you'll find that one block has been produced every 20 seconds. So you can have blocks which are 5 or 6 seconds apart, even sometimes 2 or 3 seconds apart, etc. But typically the average block density as of today is one block per 20 slots. Now, why is this important? This means that the block time is practically, you can say it's 20 seconds. And we'll see how that affects transactions, etc. When we look at setting up the testnet wallet and then funding it with some test data. Right? Now, once the epoch is created, the snapshot is taken, slot leaders are chosen based upon, it's a very advanced algorithm which sort of decides in a fair manner which particular staking pool should be allowed to create a block at a particular slot. Right? And of course, there are staking rewards, and there is no proof of work hungry mining, which consumes a lot of electricity. It is entirely through mathematical probability. In a very, very secure manner, this is done. Okay, let me just check that there are no questions. Okay, so now when we come to the, so we have looked at blocks. Now, in order for us to do transactions, we need to have an address, right? So today, if you create a Cardano wallet, basically you will get something called a Cardano base address. I mean, this is the technical term for it. You might just say, oh, this is my Cardano address, right? But what is this base address? This base address has two components to it, right? One is, if you can see here, this is, let's say, for example, a Cardano address, right? I just picked it up from my wallet, one of the temporary wallets. So this is the mainnet address. How do you know this? You have ADDR1. Right? So ADDR1 tells you that this is on the mainnet. As we'll see when we set up the testnet wallet, you'll see that if you have an ADDR_test1, then that address is meant to be used only on testnets. So you have addresses which are sort of specific to the either the mainnet or testnet, etc. So that sort of makes sure that you don't get confused about which address you're using, right? So ADDR1, immediately you see this, you understand, oh, it's a mainnet address, right? So this address has actually two components within it. It's two components which are joined together, sort of, right? So there is a payment key which is used to control your ADA tokens. Tokens, as in, let's say you're in Ethereum, you have smart contract based tokens. Here you have native tokens. We'll talk about that shortly, right? So ADA as well as tokens both can be controlled with the payment key. Now, so if you want to do any transactions, you will have to use the payment key part of the Cardano address. Now, this will all be handled by the wallet. You don't have to worry about whether, oh, am I using the right payment key or the staking key? But the address itself is made up of two components: payment key, and then there is a staking key, which takes your ADA and then sort of delegates it to a stake pool, and then it sort of accumulates the staking rewards into an account. Now, why are we having two different things? For example, in Ethereum, you've seen, right? If you're comfortable with Ethereum, in Ethereum you just have one address and you'll use that for staking as well as for transactions. Here, basically, for all practical purposes, you see it as one address, but there's two components. Why? Because Cardano is a UTXO based blockchain, which means, let's say, for example, I have 500 ADA, right? And I stake 500 ADA, and every 5 days I'm going to receive some maybe annual returns of 4% or 5%, right? So that's going to be literally like maybe 0.1 ADA, 0.2 ADA in some cases, right? So since if I'm getting these rewards and I want to use them, that means I would have a lot of something called dust UTXOs, right? Dust UTXOs are basically UTXOs of very small value, and so it becomes like very difficult to manage them, and there's a proliferation of dust UTXOs. To stop this from happening, basically Cardano uses for staking, it uses an account model where you just keep adding to an account, just like Ethereum. You just keep adding to an account. Like, for example, your bank account, when the salary gets credited, you don't print out notes, right? But your digital balance just gets updated plus equal to whatever, right? So this way, the staking account has ADA in it, which keeps getting accumulated. Whenever you want to use those ADA, you can withdraw them into your payment account. And then basically you can, then at that moment, let's say over a year, you have accumulated, say, 20 ADA, right? Now, when you withdraw them from the account, from the staking account, they get converted into a UTXO of 20 ADA. So only one UTXO is created in this. So it makes sure that it's very efficient, right? So Cardano uses a UTXO plus staking account so that it's very efficient, and you are using the blockchain for just the perfect optimal this thing of balance of power and effectiveness. Right. So now, as I said, ADDR1, this is your mainnet address. You'll see that there is a payment address. This is what will internally get used by the wallet whenever you do a transaction, right? ADDR1, etc., etc. And then there is a staking address, which is a account base. So it just accumulates the staking rewards, stake one, right? Hope this is clear. You can ask any questions about this if required. Right. So now we have talked about how Cardano is a UTXO based blockchain, right? Very similar to Bitcoin, right? But it has extended it to an even more powerful paradigm. So what is a UTXO? It's an unspent transaction output. So in plain English, I would say, if you have a wallet, if you have a real, like a real physical wallet, you can only spend the cash that is unspent in your wallet, right? So each of those notes or currency notes that's in your wallet, you can think of it as an unspent transaction output. So you got that money from some other transaction, but that's the part which was unspent, right? So you went to a store, you bought a chocolate, you paid one note, and then you got the chocolate and some unspent. So whatever was due to you back again, right? So if I spend 50 rupees and I buy a 10 rupee chocolate, then I get 40 rupees back. Now the 40 rupees is the unspent transaction output, right? I did a transaction, there was a transaction unspent output which came back to me, right? So this is a UTXO, right? Now a UTXO basically can typically contain ADA, right? Of course, I mean that's the native cryptocurrency, right? But then you can also have tokens, right? And the beauty about tokens on Cardano is they sit in your wallet. They do not sit in some smart contract like in Ethereum, right? They are not present in a smart contract and reflected in your wallet. They're actually present in your wallet as as native tokens, right? So each UTXO contains value. It can be ADA plus tokens. And well, this value, this UTXO is locked to your particular address. So when you want to spend this money, you will have to sort of unlock it with your signature, with your private key, and then you can sort of spend this. So you can create a transaction in which you spend it and sign it with your private key. And if that private key is valid for that UTXO, then the UTXO can be spent, right? And then there is an additional thing called optional data field. Now, there's this concept called datum, right? A datum is the singular of data, right? One single piece of data is called as a datum. It sounds a little more complicated, but basically you can think of it as a data field, which is in the UTXO. So you have your bag, you have ADA, you have tokens, and then you have got a small data field in which you can store some data, right? And the thing is, whenever you sort of do a transaction, for example, let's take the example of a chocolate. I buy a chocolate in a store, right? Let's say I have a 50 rupee input to this transaction, and the transaction gives an output of one chocolate, which is offline. It is not recorded on the blockchain. And then let's say 40 rupees back, right? So when you see in the store, basically you're giving a 50 rupee note. That 50 rupee note goes to the storekeeper, so it doesn't get destroyed, right? And 40 rupees that he had in his whatever accounting machine or whatever, he pulled it out and slot this thing and he gave it to me. In the case of Cardano, whenever you spend UTXOs, they actually get consumed, they get destroyed, and the output will have. So basically what will happen is you have 50 rupees UTXO being put into the transaction, 10 rupees is going to the storekeeper, and 40 rupees comes back to me. So these are two new UTXOs that get created, right? The old one gets consumed. It is marked as spent. So that means you cannot use it anymore. So this is a part of the security model of Bitcoin, which has been inherited by Cardano, right? And basically this means you have deterministic, in the sense, whenever you do a transaction, you are going to get the money back. You're guaranteed that. For example, in a store, I can give the money, and if the storekeeper says, no, you gave me only 10 rupees, then I would have to argue with him, find some way to get back that money. But in this particular case, it is deterministic, because I will create the transaction. I will say, here is 50 rupees input to this, 10 rupees will go to the storekeeper, 40 rupees have to come back to me. So it is deterministic, it is guaranteed that I'll get back the money. There's no way that the storekeeper can change that outcome, right? And it is parallel. We'll talk about this a little, right? This is a very powerful aspect of Cardano's UTXO mechanism. So we'll quickly take a look at the Ethereum model versus Cardano. I don't know how many of you are familiar with Ethereum, but basically in Ethereum you have one global balance sheet, right? Everybody's transactions, everybody's balances are sort of written in that, right? Yeah. And it's all one. It's like one sheet in which everybody's balances are there, right? Whereas in Cardano, it's more like you have currency notes, right? So if I have some currency notes, that is different from, say, the currency notes that are held by REID or by any of you, right? So there are independent UTXOs. The sum of the assets in the blockchain is nothing but the sum of all the UTXOs value put together is the value of the blockchain, right? So there are many independent UTXOs. How does this make a difference, right? You can think of this as being like a single threaded process versus a multi-threaded process. Well, it's sort of multi-threaded. The transaction itself is processed multi-threaded, in the sense multiple transactions can be processed independently of each other. But ultimately, the block production is not yet multi-threaded, right? So it is sort of multi-threaded, right? So what's the analogy I can give? Let's say you go to a shopping mall along with your family, and you are looking at some clothes. Your wife is looking at another shop. She's looking at other clothes. Your children may be looking at snacks or whatever, right? And then basically everybody comes to you and says, hey, you know what? I need you to pay at the clothing store. I need you to pay at, say, McDonald's or whatever, right? Now, what happens here is, if you have a debit card, right? Let's say you're purchasing something and you're just swiped your card, it's still processing, and then your wife and kids come and say, please come and pay for the goods that you have bought. So now, until my transaction goes through, I cannot give that, or I cannot go to the store and swipe it, or I can't even give it to her because it's still in processing, right? So at any given time in Ethereum, one transaction is actually is sort of effected, right? But for example, if you look at the Cardano UTXO concept, right? I am at the same shopping mall, same situation. I am paying, and my wife and kids come for asking for payment, right? Asking for payment to be done. I can just pull out my wallet, give one note of say 500 rupees to my wife, 500 rupees to my children, and they can go and parallelly they can get the transaction completed, right? So it's something like that. So this means that there is massive parallelism which can happen in transaction processing, which is going to be a very, very powerful benefit later on, right? So there are also lots of side effects that can occur because of account model being used, which are not present in the UTXO model, which is why Cardano, after extensive research, decided for this model. So Ethereum is congested, sequential execution. Now the other benefit is Cardano transactions are deterministic. As I said, you are going to get back your money, as well as the fees that you pay on Cardano are always deterministic. Before you even submit the transaction, you know exactly how much fees you are going to pay. Exactly, right? If the transaction succeeds, how much will be the fees that you pay? And if the transaction doesn't succeed, then you don't pay any fees, which is very different from Ethereum, where, first of all, it will show you an estimate, right? When you submit the transaction, it say, yeah, you might get charged so many gwei, right? So much amount of rupees, let's say, in rupee value, right? But then when the transaction actually executes on the blockchain, Ethereum blockchain, that could very well be, because of traffic and so many other aspects, it could very well be 10 to 100 times that fee that you end up paying, right? Whereas on Cardano, when it says, okay, you're going to pay 0.2 ADA, you are going to pay 0.2 ADA, and it is going to succeed. As long as the inputs are all valid, the transaction is guaranteed to succeed, which is not the case in the case of Ethereum, right? So deterministic parallel execution, right? Now, technological implementation can say Ethereum is easy, flexible. It allows some paradigms to happen which are quite useful, but not as powerful. But Cardano is involved. The mechanism is pretty complicated, especially when you bring in smart contracts. But it is a very powerful mechanism, right? So now I talked briefly about native tokens on Cardano. So what's the difference? So if you look at Ethereum, whenever I want to create a token on Ethereum, I have to create, there's no choice. I have to create a smart contract. I have to write the code. And when I write the code, if there's a bug, then my token has a bug in it, right? And every token is implemented separately as a separate smart contract. Now, there are solutions for this, like, for example, you have frameworks which you can use to sort of reduce the cost of development or the complexity of development, make sure you're safe and sound. But overall, you cannot create a token without a smart contract, right? But in Cardano, basically, Cardano abstracted this value model, right? It said, okay, I have got ADA and I got token. What's the difference? ADA has a name, ADA has a symbol, ADA has a value, and ADA has a denomination, in the sense, how many ADA are going to exist. Similarly, a token has a name, it has a symbol maybe, and it has a number of tokens that are going to be created, right? So if you look at both of these, ADA as well as token, logically they're the same. So why should Cardano say, oh, no, if you want a token, it's a separate thing, you'll have to write a smart contract? It doesn't make sense. So what Cardano did is it involved or included tokens into the native ledger system, and all the validation rules that apply to ADA are applicable to your tokens, right? So what does this mean? What are the things you do with a token, right? You create a token, you transfer a token from one person to another, from here to there, etc., etc. And potentially for some tokens, at the end of its life cycle, you might burn it, right? These are by and large, these are the operations that will happen on any token, including ADA. Of course, you don't burn ADA, not like Ethereum or this thing where you burn Ether, right? But typically you don't have to burn ADA, right? But a token can be burned. Even ADA could be burned, but you don't want to burn them, right? So create, transfer, burn, these are the main operations which are there for any token, whether it be ADA or otherwise, right? So, well, the ledger has already got rules for creating ADA, transferring ADA, and burning ADA, right? So it's the same kind of thing abstracted to allow tokens to be. So the ledger itself understands tokens, which means you don't need smart contracts to create a token, transfer a token, or burn a token, right? And this is all without any code. The same ledger rules which are applicable for ADA are applicable for your token, and that makes it incredibly secure and incredibly efficient, because every time you want to transfer a token, I don't have to load up a smart contract, process it, and then save the state, etc. Right? The ledger itself says, okay, Bharat had 500 Husky tokens, or 5 million Husky tokens, and he transferred 1 million Husky tokens to Ariadi. So just debit Bharat's balance of Husky tokens by 1 million and give that to Ariadi. Just add it to Ariadi's account or Ariadi's wallet. Right? So benefits: lower cost, no ERC20 style contract complexity, predictable and incredibly secure behavior, and very, very efficient. Right? So Cardano just says tokens are ledger entries, not code. So no bugs in basic value transactions possible. I think there are a lot of questions about team building. That's something that I guess Nidhi will take care of, or the Hack to Skill team will take care of, right? We are only here to share our knowledge about Cardano, right? Now, you understood that UTXOs are a very, very powerful paradigm. And how's the time? I think half an hour. Okay, I think I'll have to go a little faster. UTXOs extended for smart contracts is basically extended UTXO. You have something called validator scripts. So on the UTXO, there is a script which will sort of check whether when somebody wants to spend that UTXO, that spender will sort of give some data to the smart contract saying, hey, I want to be able to spend this, I am the owner of this, right? And it gives some proof of that, or some conditions, like if the date is more than March something 2026, then you can spend this, right? Whatever it be. So the condition is in the validator script. The UTXO is locked with that. There is some data which is also stored in the UTXO, and there is the redeemer. Redeemer is basically whenever somebody wants to redeem those UTXOs, they will create a transaction in which they give the the private key or whatever, some conditions that are there, right? The conditions that should successfully unlock that UTXO. So that will be called. The redeemer is a function which you call, and you provide data with it. If that data is valid and it it passes the validator, then the UTXO is unlocked and it can be spent. Right? It's very similar to how a normal transaction happens, but instead of a hard-coded ledger logic, now you have a smart contract logic, which is complicated. Right? So predictable execution, which means again the same thing. You know the fees upfront. You know that the transaction is going to succeed as long as the assets that you want to transform are available. For example, DEX, you want to purchase some, or an auction, you want to purchase an NFT. You give the transaction saying, I want to take this NFT and pay so much money to the seller. Right? Now, if the NFT is not sold, then it will succeed, guaranteed. Right? But if it is sold, for example, and the input argument is invalid, then basically you will not incur any costs. And even if the transaction fails, you will not incur any costs. Your money comes back to you. There are some situations which are again deterministic and predictable. You can submit a smart contract transaction which might fail, but if you have done your testing on your front end beforehand, right, and then because it is deterministic, if it fails on your side, it is going to fail on the blockchain. If it fails on the blockchain, if you have to simulate the transaction on your own end, it would fail as well. So if in spite of this you have submitted a transaction, then you lose some money or some sort of collateral because you have submitted a malicious transaction. Right? Okay, cool. So as I said, networks, mainnet is of course where the live network with real ADA and real smart contracts where you can make money, real money. And testnet is a safe sandbox, right? So today what we're going to do is we're going to run Eternal. We are going to set up Eternal. We are going to set it up for preview testnet, and then we are going to try and get some free ADA, right? Free test ADA, not real. Okay, so first thing I'm going to do is I'm going to go to Eternal right? So eternal.io is the website. So I'll go there. Right. Oh. Oh, okay.
I think we're facing some network issues from Bharat's end. Yeah, he's just joined back.
But
Yes,
I don't
hello
know why my
everyone.
phone just
That's
crashed.
okay. Welcome back, Bharat.
Yeah, I'm back. I'm back. I hope. Okay, I'll have to present again, I guess. I guess there was some issue with the sharing screen or something. So, yeah, here. I hope my screen is now visible.
Not yet.
Yeah,
It's still
okay. I
loading.
think it should.
Yeah, we can see it now.
Yeah, okay. So once you go to eternal.io, I think there was some issue there which crashed Chrome. So start setup. Okay. So now what's going to happen is my currency is in dollars. Fine. Well, wait a minute. So I'm just going to 0000. I'm just going to give a pin which is easy. Well, you shouldn't be doing this for your mainnet wallets. Right. Now it's going to load. Right. Now, in this particular case, I want to make it on preview. I'll save a step. I think I forgot. Okay. Will it crash again? Why? This is not the normal flow of path.
Yeah, I think
I
this is
wonder.
the old version of Eternal, Bharat. Maybe
Yeah, I have uninstalled it. I don't know why it's showing up. Okay, maybe I'll just try. Or maybe I have to reload it. Yeah, there it is. Right. So now it's on the preview testnet. Sorry, it might be a little confusing, but if you open it in your particular browser, you won't have this issue because I just uninstalled something which I had created. Okay, you want the link. Okay. Right. I have put it into the, oh, sorry. No, that's in the wrong place. So eternal.io has failed to post. I think there's some security, this thing for HTTP links maybe, right? So whatever it may be, just go to eternl.io. Okay. Okay. I think the admins have to put that. So just select preview because we are going to set it up for preview. Create a new wallet. Now, in this particular case, it's just this thing, right? So what I'm going to do is I'm just going to select this, and then I'm going to put it on a new, right? 1 second. I'll just put it on a notepad or whatever, and then I'll say next. So normally you won't share this to anybody. It's your private key basically, right? Your mnemonic phrase is your private key. So never do this in a public place. Make sure you do it in a secure way. And as far as possible, write this down on a piece of paper. Don't save it in your Gmail or in some notepad, etc. Right? For security purposes. Right? Whoever has these keys, they can control your radar, basically, right? So now it's saying seventh word. What's the seventh word? It is, in my case, it's summer. Then pick the fifth word. Fifth word is income. Pick the 12th word, town. It'll ask just a few. Normally, earlier you had to input every word, but now it just sort of checks and makes sure that pick the 19th word. 19th word is meadow. And then 13th word is isle. Right. So now I'm just going to create two accounts here, right? Because I'm going to create one for receiving ADA as well as then I want to create one for sending to ADA, right? So I'll just create 2 accounts. Next, and I'll just say temporary demo wallet. You can give it whatever name you want, right? And then I'll just give it a too simple is what it says, but it allows me to create it. Normally for a real wallet, you won't do this, right? So now it's creating my wallet. Okay, cool. So now you can see here account number 0, it has these. Now, basically, you just created your wallet. So if you want to know what's your address, you can see here there's a staking key which has been created. It doesn't make any difference to you. If you go to transactions, you'll see this account has no transactions, which means it's completely brand new, right? Now receive, if I click on receive tab, you will see this address. So I can just copy that address. Now what I can do is I can just search for Cardano testnet faucet, and then in the Cardano docs you have a testnet faucet, right? So just click on that link. So this is the testnet faucet, etc. Now, unfortunately, just before this demonstration, I actually tested this, and the testnet faucet only allows from one IP address, or for one address, it will only allow one transaction. It's a rate limiting kind of thing. But so here I have selected preview testnet, and I want to receive test ADA, right? So that's the action I want to do. And here the address, I would just paste my address. So you can see here, oops, ADDR_test1. So as I said, this is a testnet address because it is very clearly prefixed as ADDR_test1, right? Now, API key, if you are somebody who has privileged access to this faucet, you would be able to do this. Now, I'll try this. But I'm pretty sure I will not get funds. Yeah, rate limit exceeded, please try later, right? So in your particular case, when you set this up, because my IP address sort of gets logged, and then if I try again from that same IP address, then it's not going to allow me, right? So that being the case, if I were to do this and it succeeded, request funds, then basically you go back to your wallet and you'll see 10,000 test data here. 10,000 test data. That sounds like a lot. It's totally useless, right? So let me do one thing. In this particular case, let me sort of reload my wallet here, just so that I think we should stop here. We are 11:15, so we have time for Ariadi to take over. So basically, if you have done this process, you set up an eternal wallet for preview testnet, you copied the address, and then you sort of pasted that into the faucet, you will get the 10,000 test data, right? Unfortunately, I couldn't show that to you because I had to test it to make sure it works right before this, and there's a rate limit. So with that, at least this part is done. Right now, 1 second, let me put it on slideshow. Right now, we have done the setup of Cardano wallet, and we have so-called funded the testnet wallet. This is the place which you should go to. Maybe I can share these slides with the organizers, and they can keep it as a public resource, right? So now over to Ariadi, who's going to sort of take it to the next level with how to create an Aiken smart contract and deploy it, which includes setting up of the development environment, right? So I'll stop my share.
Yes, thank you, Bharat. And hello, everyone. I'm Ariadi. Next up, we'll set up our development environment, and also the goal at the end of the session is for everyone to have Aiken running and have a dummy smart contract deployed on the Cardano testnet. So first, where is Aiken? Aiken is located here on the aiken-lang.org. Maybe someone can please share the link. So what is Aiken? Aiken is a scripting language to create smart contract on Cardano. It is one of several other options, but at the moment, Aiken is the most popular language for people to develop various types on Cardano. And if you visit the website, you can see what the language looks like. It's very approachable to learn, and you can get various other informations like what is Aiken, who built this, and so on. But what we're interested in how to set up Aiken. So you can just go to documentations. So if anyone can follow along, please do so. But if not, you can watch the recording. And when you visit the documentation page, there are various methods where you can install Aiken. But the one that I recommend is to install it manually instead of via Aiken.
Ariady, just one thing. Can you just zoom in a little bit so that it's a little easier for them to see it?
Is it better
Yeah.
right now?
Yeah, this is good. This is good.
Okay. Okay, so there are various method of installing Aiken, but what the one that I recommend is you go to manually and then install via npm. Why? Because so far this always works. It never fails. As for Aiken, Aiken is the package manager for Aiken. It's similar to NVM if you are coming from Node.js. So given that we are going to install using npm, so the prerequisite is of course that you have installed Node.js before. And if you have not, you can go to nodejs.org and just download the LTS version, and it's according to your particular OS. And let me just copy this from Aiken website. It is npm install -g aiken-lang/aiken. And if I go to my terminal here, right now I don't have Aiken installed yet, but I should already have Node.js. So what I'll do is I'll paste the command here and wait for the installation process. And once it's done, we can just verify if Aiken is installed. You can just run the Aiken command and it should show something. And the next step is this auto completion is optional. I personally don't do this, but if you want to do this on your own, it's okay. But this one, editor integrations, is highly recommended. And since I assume everyone is using VS Code, let's just install the extension for VS Code. So for my end, I already installed it. I just need to enable Aiken on this particular environment. So next, what we can do with Aiken? Well, we can initiate a project. So the command to create a new project on Aiken is, you see here, it's Aiken new. Aiken new, and you can see the help, how to initialize a project, and it's just project name. So the convention in Aiken is that you provide some GitHub username. So for example, my GitHub username is Ariady, and let's just call the project name is live session. Let me, yeah. So right now, this part is my GitHub username, and then slash, and then the project name for Aiken. And in Aiken, the naming convention is snake case, so it's lowercase with underscore. So once we do that, Aiken will create a new. All right, so I should, yeah, let me take this out because I shouldn't do it here. What I should do is I should go to the root and I will repeat the process. Aiken new live session. So Aiken will create this new Aiken project. And there are several files here. There is the README. Let me, yeah, there is this README, and then this is Aiken toml. So the toml file is kind of like a package.json file. This is where your project's configurations, and at the moment we only have one dependency, which is the Aiken standard library. And there is this git ignore file, and there are several other folders. And Aiken also already provided us with a validator script. It's placeholder.ak. So .ak is the Aiken file extension, but this is not the one that we are going to deploy on the Cardano testnet. So to speed things up, I've already created a repo here. It's on GitHub, Kickstart Cardano Hello World. Let me share the link. So what I urge everyone to do is to clone this repository, and this is an Aiken project with a dummy smart contract here. So this is kind of similar structure with what we have created, but there is an off-chain here. So this is a front end which we will use to interact with the smart contract that we've already created. So this is a dummy smart contract. It doesn't really do anything meaningful, but don't worry if this looks overwhelming at the moment. But you can.
So Aryadi, just a request. Could you sort of help them understand what is this on off-chain and on-chain aspect a little bit?
All right. So on the blockchain development, we have the on-chain part and the off-chain part. So the on-chain part is just this logic that whatever logic that we put in our smart contract, and then from the off-chain is where we interact with the smart contract that we have already created. I hope it will be clearer once we do the thing. Okay. So right now we have only one validator block, and inside this validator block we have mint and spend, meaning that this particular smart contract will handle either mint action or spend action or both in the same transaction. So how can we build this? Well, we can just open in terminal and run Aiken build. Now, when you run Aiken build, Aiken will generate this Bluetooth JSON file with the compiled code inside. But what I recommend during development is that instead of running Aiken build, we can add a parameter here called verbose, because with just Aiken build, it's by default, it's built in silent mode, meaning if there is an error, the error will not be printed when you interact with the smart contract. And for Aiken build, there is a shorthand. You can just call Aiken B -t and then verbose. And you can read the instruction here on the README how to build it. And then once you get the Bluetooth JSON file, what you can do is you can find your compiled code here. And if you take a look at the file on your own time later, you might notice that right now, other than this one, we also have another one. But if we check the script hash, so this is the hash of the script, all three hashes are the same, meaning that all these three scripts are the same. So it doesn't matter which one you copy. And just for information, why there are seemingly duplicated code here, this is just coming from the Bluetooth V2, because back then in Bluetooth version 2, each validator will have different compiled code. But in Bluetooth V3, we have this feature called multi-purpose validator, meaning that a single validator can handle various types of script purposes. And in this case, it is why, regardless of which script you compile, it will generate the same hash here. And the thing that you need to copy is this one, the compile code. You copy this one, and then you go to the off-chain. In the config, in the script, you replace this with your script later. But before we do that, what I recommend is that, since unlike on other blockchain, let's say Ethereum, whenever you compile a Cardano smart contract, as long as the logic is the same, it will always generate the same script. So let me, just to prove to you, let me copy this script hash, and let's just create a new file to store the hash. So this is our current hash. And if we recompile, if we rebuild the script, nothing should change. So this should be still the same script hash. But if we change just a little bit, let's say, so I have a logic here. This is just checking two conditions, whether this first condition and also this condition, if we just flip this, let's say we just flip the order, if we rebuild this, I think the script should be generated in a different hash. So you see, previously this is our hash, and just a single character changes. I mean, if it's a meaningful changes, I mean, if you're changing the comments, it doesn't count, but you should understand the point here. So basically, that is why if everyone compile the same script, everyone will get the same address. So in that case, I recommend if you clone the project, you change something here. Let's say change the string here to your name, so that everyone will generate a different address. So nobody will collide with each other. So what this script will do is we will mint a token and we will validate the token name to be your name later. So we'll recompile, we will rebuild this Aiken script, and we'll copy the compile code, and you see the hash should be yet another different hash. It's a different one. We'll copy this compile code here to the script, and let's just save it. And again, the instruction is also here available on the README. You copy the compile code and where you should replace the script. And then next, what we want to do is we want to go to the off-chain. And then the first time you run this, you need to install the dependency. So I'm using pnpm. So make sure you if you have not have pnpm installed, you can run npm i. Let's do pnpm. And I already have pnpm installed, and then you can run pnpm i to install the dependencies. Yeah, I'm not going to do that because I already done it. And then to run the front end, you can just run pnpm dev. And since this is a Next.js project, you can just go to localhost 3000 and wait for a moment for the project to initialize. Right now it's still compiling, and shouldn't take too long until it's done. Okay. Okay, yeah, I'm not sure why it's kind of slow at the moment, but this is a very simple UI where we have a wallet connector here, and I also have already Eternal wallet installed and set up, so I can just connect to Eternal. And before we can connect to any DF, what you need to make sure is that you select your account, and then, well, let me show you a different one. So this one, you make sure that you use this particular account that you have to be connected to be connectable to any DF, because otherwise you cannot interact with any DF. So let me just connect back with this the first account that I have, and let's just connect the wallet. And here we have two entries here, and this should be your wallet address here. This one.
Can you zoom in a little? Is it possible to zoom in here?
Okay.
Yeah, that's better.
Yeah. So there are two sections here. Basic transaction. This is no smart contract interaction. This is just to verify if everything is working properly. You should be able to click this and then to transfer something to a different address. So let's say I have multiple accounts here, so I can just copy the other guy's address, and let's just transfer, let's say 50 either, and let's ignore change address for the moment. This is the same address as your connected address, and if everything is working properly, you should see this kind of pop-up. And if the transaction detail is not shown to you automatically, you can click on this thing, send funds. You click on it, And if you want to have this to show up automatically, you can go to your Eternal, go to settings, and then the app settings. You enable the Pro mode here, and automatically open the transaction preview when you sign in. And check out all other settings here, because like there are other things that show a bunch of useful information. This can be overwhelming, but when you are developing, this is recommended. So you can see what things are going on when you submit a transaction. So let's just submit this. So right now, the transaction should be submitting to the blockchain, and it means everything is working properly. Now, the next section, we have this hello world. So hello world is our dummy script that we just deployed. So on Cardano, unlike on other blockchain, when people talk about deploying a smart contract, what's actually going on is we put this particular script into a UTXO somewhere. So let's just do it. And hopefully the previous transaction still, well, let me cancel it for a moment. Let's just wait this to succeed, because I'm not sure if I only have one UTX or not, because we might not be able to submit the other transaction if I only have one UTX. So while we are waiting for this, let's take a look at the
Aryadi, there
option
is a
code.
question. Could you explain how the app running in your local host is connecting to the Eternal wallet?
Yes, so the option is a front end. There are a bunch of components, and one of which is a wallet connector. So if we refresh this again, this component is a wallet connector. It will detect what wallet extensions are installed on your browser. And on my particular browser, I only have Eternal installed, so that is why it only shows Eternal. And the exact code for this is also available here in the project, but it's not something that we will worry about at the moment, because what we are interested in is how we can deploy the smart contract, and then
So basically, you
how we
can
can
think of it as there is a library or the framework which sort of gets included into your project, which allows your local host application to sort of interface with the Eternal wallet.
Yes, thank you, Bharat. So yeah, um, where was I? Oh yeah, so we want to see the dashboard. Let me make this smaller. I hope it's still acceptable. So anyway, here's the code. So we want to deploy something. So this is our script, which we pasted here. We want to deploy this script, and how we do it in Cardano is that we send this information into a UTXO, meaning we are sending something, and we don't set any datum, we don't set any assets, and if we don't set any assets, by default it will set a minimum ADA just to cover the cost to put this particular script here. And then since our previous transaction has already been submitted successfully, we can just click on deploy. And then here you can inspect in the output, there are two outputs. So this is what Bharat was telling you before about the 50 rupee buying a chocolate for 10 rupees. So this is kind of like that. So instead of buying a chocolate, we are putting some scripts
Can
here.
you zoom in a little bit?
Yeah, this one unfortunately not, because I'm
Okay.
not sure. Yeah, this
Oh,
is
it
part
doesn't
of the
open up.
UI. Yeah,
Yeah.
yeah. I cannot control this internal UI. But when you are doing it on your own, I hope you can inspect this. Even if I
Yeah,
maximize
maybe you
this,
can maximize that. Yeah.
yes. So yeah, unfortunately, it's with the UI. So here you can see one input is taken from your wallet. This is the 50 rupee, and then we put something to another address here, and it costs us almost 4 ADA is 3.9 ADA, and then the remaining value goes back to your initial wallet address. So let's just sign this. And then, yeah, we don't need to, well, actually we need to wait for this to submitting, but while we are waiting for this, let's go back to the code here. Now, next thing that we want to do is we want to mint something, because since our script allows minting something with a certain condition that the token name, again, the token name must be your name. And here there is a kind of branching of logic. So here I'm browsing the validator address and I'm looking for the script that we have just put. But in a real production app, in case you already know which UTXO is there, then you can just specify to that particular UTXO rather than browsing the entire address. But since right now this is a new script and I don't know yet what's the address previously, so that is why I browsed the entire address to look for the UTXO. And then what we want to do is we read from that UTXO and then we do the transaction, which is we win something and then we attach some metadata. But in this case, if the script is not available yet on the UTXO, we will manually attach the validator. So in this case, yeah, it's already submitted, so we can do something. But let's say, let's create a token with a wrong unexpected name. So again, the expected name of the token is my name, but since I provide a wrong name, well, this one is not checked on the on-chain. This is just to specify the image for our token. We can just submit this, and then we should see some error message here. Token name equal my name is false. And where this is message coming from? It comes from your smart contract here. So in Aiken, there is this question mark thing. It's called trace if false operator, meaning that if this condition is false, then it will print something. So let's do the correct way according to our script. If we submit this, it should be successful. And how we can tell it's successful? There is this eternal pop-up here. Well, I don't clean the message, but this means we can submit this transaction. And you can see here, previously we have one input and two outputs. Right now we have one input to pay for the transaction, and then we also have another one reference input. So this is where the script that we refer to instead of attaching to the transaction. And every time we interact with a smart contract on Cardano, they will mandate us to, it will automatically collect some collateral to pay in case something fails with the smart contract. But it's almost never happened. In fact, for me on mainnet, I've never experienced my collateral getting slashed. So in this case, as you can see, in the input, we provide only some ADA, and then in the output, we'll get a new token here. So let's just sign this transaction. And if it's successful, it will show you the TX hash. And you can browse this TX hash on Blockchain Explorer. Since we are on the preview, we can go to preview.cexplorer.io, and then you can paste your TX hash here. Yeah, I'm not sure. Anyway, we can just take a look at the wallet. And once this transaction is submitted, if we go to asset, you should see in a moment that a new token will be created, which should be in my name. And if not, we can just refresh this. Yeah, it takes a while, but yeah, this is the token that we just minted. And the metadata is very simple. It's just the token name and then the image that we provide here. So basically that's all how we can deploy and interact with it. And then there is another stuff with span. So if we take a look at the code is even simpler. We don't utilize the datum yet because in the next session, you will be guided into more deeper with the actual development. This is just a dummy script. So here we can spend if we provide a redeemer with value 42, and if we go to the off-chain code on the spend part, we provide a redeemer here, and the value is 42. And let's say if we provide a wrong value, in fact, instead of an, well, on Aiken it's called integer here, but on TypeScript it's going to be a big integer. But right now we'll test what will it look, what's it going to be look like if we provide an unexpected data type here. So you see the expected redeemer is integer, and we provide a wrong value, meaning that let's say the expected value is 42, but right now we are providing 43. And if we do that again, it will print similar to the previous mint action. And again, this message is coming from your script. So you can play around with this script and together with this option, and you can pass around to see the message. And right now we will just spend and every UTXO inside this particular smart contract address. And right now there is only one UTXO, and this is the script that we deployed in our first action here, and we want to consume this. And based on the logic in our script, as long as we provide the redeemer value 42, then anyone can spend this UTXO. And we'll just sign this transaction to get our ADA. And yeah. Yeah, remember what Bharat said about the block time? It takes at least 20 seconds, but if the network is not busy, sometimes it takes longer. So yeah, in this case, it's about that much of time. And I think that's all from me, and it's about 2 minutes left. And yeah, in case there is any question, please.
Yeah. So I think we can try to go for the Q&A now. So if there's any questions, I think people did ask a few questions and they were answered. But in case there are any specific questions, please feel free to ask.
So we have.
I also shared the slides with Nidhi, so she'll be sort of putting it up in the resources section soon.
Yes.
Also, I posted a link to the Cardano Foundation's Academy, where you can actually go, and if you are interested in learning Aiken or even Cardano blockchain fundamentals to some extent, you can go to the free academy which Cardano Foundation has created, and you can sort of learn from there. Right? So that has also been posted into the comments.
Yeah, so I think mostly the comments that were in the comment section, we have addressed most of them. But Bharat and Narari, there were some pre-submitted questions to us as well regarding this workshop that I would like to bring on table.
Sure.
Which is can you explain eUTXO in 60 seconds? How it is different from Ethereum's account model, and what does that change in how I design my DApp?
In 60 seconds it's going to be challenging, but see, basically in Ethereum what happens is any kind of transaction, smart transactions that you do, you are basically submitting a transaction to a smart contract, right? And there's some Ethereum EVM code which gets executed for that, right? Now here it's a little different because in Ethereum your smart contract controls all your assets, right? Here what happens is you have a UTXO, and that UTXO is locked with a particular script. So if there are 20 different UTXOs, there could be 20 different locks, but the script is pretty much the same, right? So whenever you want to spend that UTXO, you will have to sort of call a redeemer and give it some data, and if that validates, then basically the transaction goes through. So well, the difference is Ethereum uses EVM, interpreted. There's an Ethereum virtual machine which interprets everything. Here it's something called Plutus core, which is used. So Plutus is a language which is based on Haskell. It is very deterministic, and it is guaranteed to run efficiently as well as deterministically. So that may be some minor differences.
Okay. And another question is, what are the most common errors when building submitting transactions? Example, collateral, minimum min ADA script size, and how do I fix them quickly?
Okay, Ariadi.
Can you repeat what the min ATS?
Can you
I'll
repeat
repeat the
the?
question. What are the most common errors when building submitting transactions? Example, collateral, min ADA, script size, and how do I fix them quickly?
Okay, so in Cardano, for every UTXO, you need some minimum ADA locked inside the UTXO, and that value is automatically, if you are using, well, any library like Lucid or Mesh, it's automatically calculated for you, so you don't need to manually set how much ADA you need to put in a UTXO, but basically all UTXO requires that minimum ADA. So that is why, if you recall, when we deploy our smart contract, there are about 3.9 ADA locked alongside that UTXO, because we put some more other information, and that is the minimum ADA.
Great. Thank you. Thank you, Ardi. Also, one more quick question I have is, what is the fastest way to go from zero to my first test net transaction, wallet setup, getting test ADA, sending a TX, and seeing it on the Explorer?
So probably Ariadi.
Yeah, no, I was
I mean,
going to answer.
we already walked through the setup of the wallet and how to fund it. I think Ariadi has also shown how to sort of do a basic Aiken project. So I guess
Yeah, sure.
that
One
question
more
is answered.
question we have.
Is Aiken the only way to build in Cardano? Are there other methods? Yes. So basically, when Cardano programming, smart contract programming started, it used to be done in Haskell and using a specific language called Plutus. Now there is Aiken. There's many other languages. There's Option. There's Helios, and so many other smart contract based language frameworks which you can use. But probably Aiken is one of the best ones right now, because it is both. It's become the standard for the industry. But there are other ways. There are equally popular ways of doing so. You can, for example, if you are using Option, you can use Python to write your smart contracts, which is quite interesting, right? So yeah, there are other methods. And the things, where does UTXO come in the example shown in Aiken? Well, UTXO is the value system of the Cardano blockchain. So whenever you're doing any transactions, those will have to reference UTXOs, right? For example, if you have, let's say, an auction smart contract which you are building, right? Then the token that is being auctioned will be in a UTXO, right? So that UTXO has to be part of your input parameters to the transaction, right? And in this particular case, in Aiken, you would reference that UTXO.
Great. Thank you. Thank you for answering, Bharat and Aridi, about that. We have a few more minutes with us. If you people would like to ask any questions regarding about your ideas and project to Bharat and Aridi. Uh, till then, is there anything, Bharat and Aridi, like just a quick tip that you would like to share with the participants, how they can excel? Just quick pro tip from your experience,
You
that
mean
would be great.
specific to the hackathon?
Regarding to their ideas and projects, they can submit regarding to the Cardano and Icon, like a quick pro tip you guys can share.
Probably Ariadi will be the right person to. In the meantime, can you just post the link which Ariadi had put in the
Yes.
chat?
Yeah, I would say maybe just follow the workshop and, well, do the exercises.
Just give me a second.
Okay. Yeah.
Okay, so I think we have covered most of the comments as well. And whatever comments you guys, more questions that you have, you can share it with us at support@hacktoscale.com. We can always get back to you. Thank you for joining today's session. And a big thank you to Bharat and Aryadi for sharing their expertise. For further questions and support, please reach out to us. And thanks, everyone.
It was a pleasure being here. Thanks so much, Aryadi, for coming in and sharing your knowledge as well. Uh,
Yes, thank you, everyone.
Thank you.
Take
Thanks,
care,
everyone.
everyone. Best of luck for the hackathon.
Thank you.
Bye, everyone. Take care.